Ready to go. We are looking at the January 2020 Physical Setting Chemistry exam, and we are going to go part by part, so you're going to see how to answer these questions. So let's get right to it. We're going to start with part A, which is 30 multiple choice questions. These are the easiest multiple choice questions on the exam. So if you're having to think long and hard about the question, think really deep, multiple steps, you are probably making it harder than it needs to be. Okay, so remember, the first 30 multiple choice questions should be easy. All right. Which statement describes a concept included in the wave mechanical model of the atom? This is the current model of the atom. Protons. So before I do that, what does the current model of the atom look like? Well, we have a nucleus in the center. The nucleus contains protons and neutrons. Protons are positive. Neutrons have no charge. And then around the nucleus, we have an electron cloud where most likely electrons are going to be found, but we can never truly pinpoint their location. So are protons, neutrons, and electrons in the nucleus? No. Are electrons orbiting the nucleus in shells at fixed distances? No, they're not. In this electron cloud, the electrons like okay. Atoms are hard, indivisible spheres? Absolutely not. That was Dalton way back before, Thomson did the cathode ray experiment. Electrons are located in regions called orbitals. Ding, 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 ding. Okay. As an electron in an atom moves from a higher energy state to a lower energy state. So we have an electron. It's in a higher energy state, and then it moves to a lower energy state. So what happens? Well, it is going to release the energy it has. You should have been able to eliminate these two options because that does not make any sense. We're not adding or removing electrons, they're just moving around. So when it falls from excited state to ground state, it releases energy. Two atoms that are different isotopes. Okay, so before I even read the question, let's think about isotopes. Isotopes have the same protons and different neutrons. Same element, different mass number. So, different protons? No. Different protons? No. So, same protons, same neutrons? No. So this is truly, again, a definition question. All right. The element in group 14, period 3. Oh, guess what? This is an easy peasy reference table question. So I need to open up to my periodic table. And I have the word group right here. And that means this is group 13. This is 14. And then I also have over here the word period. So this is period 1, period 2. All right, so what did I need again? Group 14, period 3. So period 1, period 2, period 3. Go across on period 3. Right here. Hopefully that's an option. Okay, now I don't want to know the exact element. I want to know is it a metal, a noble gas, a metalloid, or a non-metal. So do you remember what it was? Group 3. 14. Okay. Here's the staircase. Elements that are touching this staircase, right? The long lines of the staircase, not the corners, are metalloids with one exception. Aluminum is a metal, and hopefully you should know that. So what are the metalloids? Boron, silicon, arsenic, continuing on like this, and going up this way. Again, one exception, aluminum is not a metalloid, it is a metal, but this one is a metalloid. Which element has chemical properties that are most similar to potassium? Well, potassium, is K. K is in group 1. K has one valence electron. The electrons that are most similar to potassium in terms of chemical properties will be in the same group Okay, so is calcium in the same group? No, it's here. Cesium, there it is. Let's just check these. Nitrogen and sulfur, well, they're like all the way over here. So it was cesium. Which element requires the least amount of energy to remove the loosely held electron from a gaseous atom in the ground state? This is a long words to ask which one has the lowest ionization energy. And where do we find ionization energy? We find it in table S. So it's the very first one. So I need sodium. What is sodium? 496. Argon. Where is argon? 1521. Phosphorus. So we need phosphorus. 1012. And we need chlorine. 1251. So which has the lowest Na, which makes sense, okay? Because metals lose electrons. So it should be easier for a metal to lose its electron, right? Which terms identify two different categories of compounds? Well, covalent and molecular are literally the same thing. Covalent is a type of a compound, and empirical is a type of a formula. All right, ionic and molecular, maybe. Ionic and empirical. Oh, again, empirical is not a type of compound, it's a type of formula. So ionic and molecular. It could have said ionic and covalent, because covalent and molecular are the same. Which statement describes the energy and bonding changes as two atoms of fluorine become a molecule of fluorine? So let's write what that would look like. Two atoms of fluorine become a molecule of fluorine. So first of all, is that forming a bond or breaking a bond? Well, that's forming a bond. So now I can eliminate the breaking options. So now I'm down to a 50-50. That is always a win. So what happens? Here's how I want you to remember. When you break something, you have to add energy in, absorb it. So when you form a bond, the reverse happens and energy is released. Which part of a calcium atom in the ground state is represented by the dots in its Lewis electron dot diagram? Well, that is valence electrons. Valence electrons are shown in a Lewis dot diagram. So I already can get to a 50-50. It doesn't show protons and it doesn't show neutrons. So let's just double check calcium. I could tell you what makes more sense to me, but let's just double check. Here's calcium. It has first energy level, second energy level, third energy level, ding, 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 fourth energy level. It has two valence electrons. So it would look like this, two dots. Based on table S, an atom of which element has the strongest attraction for electrons in a chemical bond? Well, that is, you are being tested to see if you know what that vocabulary word is, and that is electronegativity. So I go to table S and I look up the electronegativity of these elements, and I see which one is strongest. So aluminum, 1.6. Chlorine, 3.2. Magnesium, 1.3. And sulfur, 2.6. So which has the strongest? This one, right? It's just a matter of looking it up on table E and double checking the numbers. You should have realized it had to be a nonmetal, because nonmetals are good at attracting electrons. But the two nonmetals, sulfur and chlorine, you may have had to look up to remember. Which substance cannot be broken down by chemical means? So what that means is an element. If an element is broken down, that's a nuclear reaction, not by chemical means. So this I definitely know is a compound. This I definitely know is a compound. So between these two, do you know which one is the element? You should. It's aluminum. Which statement describes the particles of an ideal gas based on the kinetic molecular theory? Okay, so the particles are tiny, there's no attractive forces, they're moving in rapid, random, straight lines, and let's see if one of those makes sense. There are attractive forces. No. The particles move in circular paths. No. Random, straight line. The collisions between the particles reduce the total energy of the gas. No. The collisions are elastic, meaning perfect energy transfers. The volume of the gas particles is negligible. What does negligible mean? Very small compared to the total volume of the gas. Yes, that means they're tiny. What is the amount of heat released by 1 gram of liquid water at 0 degrees Celsius when it changes to 1 gram of ice? Now, this seems like it's going to be a calculation, but I'll show you. So, ice melting, heat of fusion, so it's this formula, Q equals mHf. But what is the mass? 1 gram. So all I need is the heat of fusion. But it's not in the problem. Where do I find it? Oh, you probably guessed it. It's on the reference table right here. Okay. All right, which term identifies a type of intermolecular force? Okay. Covalent bonding is a bond between two non-metal atoms, not between molecules. Ionic, so it would be between, for example, carbon and hydrogen. That bond. That's an intra, within the molecule. Ionic bonding, like between Na and Cl. Metallic bonding, like what happens between a whole bunch of atoms of magnesium. Intermolecular force, hydrogen bonding. That's the strongest intermolecular force. It gives water its incredibly unique properties. Which statement describes a reaction at equilibrium? Okay. Equilibrium has two things. It says, as key things, rates are equal, concentration, remember, constant. We have a closed system. It's dynamic, right? So does equilibrium say anything about mass? No. Does equilibrium say anything about entropy? No. Does equilibrium say anything about moles? No. Does equilibrium say the rate of formation of the products must equal the rate of formation of the reactants? Yes. It's a little bit of a weird way to word it, but basically it means the rate of the forward reaction must equal the rate of the reverse reaction. Because here if we have reactants to products, the rate of forming the products, forward. Rate of forming the reactants, reverse. Entropy is a measure of disorder. That's just know it, right? Systems in nature tend to undergo changes toward. Okay. Think about this. Things want the easy way out. Would the easy way out be high energy or low energy? It would be low energy. So high energy is definitely out. And do systems tend to favor less randomness? This is entropy. That's what randomness is. Or greater disorder. Well, think about this. If you open up a pack of M&Ms, right, and you have a whole bunch of different colors of M&Ms inside, that's disorder. If you wanted to sort them into piles based on their colors, would that take energy? Yes, the heck it would. So that means if I have order, right, if I have less randomness, that takes energy. That's the opposite of what I want. I want the easy way out. So I want low energy and greater randomness, because to take away the randomness takes energy. Okay. Which organic prefix is matched with the number of carbon atoms it represents? If you don't know it, please don't guess. Just use this. Use table P. But it's this one, Hept 7. Which terms represent two types of organic reactions? Well, here's the acronym I gave you for remembering the types of organic reactions. Polymerization, saponification, fermentation, addition, combustion, esterification, and substitution. Was sublimation one? Absolutely not. Okay, so now I'm down to 2. Saponification, yes. No. Here we go. All right, next one. Given the organic functional group, which class of compounds? Oh gosh, I love this question. Super easy. All I have to do is look in table R and look for that exact same functional group. Here's the title, class of compound, go across. Ding, 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 ding. Aldehydes. Which particles are transferred during a redox reaction? Well, remember this phrase, Leo says Gur. What particles are being talked about? Electrons. And remember this, the number of electrons lost has to be equal to the number of electrons gained. All right, which process can be represented by a half reaction equation? Well, half reactions show what? Either Leo or Gur. So the only one that works here would be oxidation. And last one here. Which form of energy is converted to electrical energy in a voltaic cell? So this is, you should remember it, it's chemical. In a voltaic cell, it's chemical to electrical. In an electrolytic cell, it's the reverse, electrical to chemical. Okay. All right, let's continue on. We're almost done with our part A. So we have question 25. In a neutralization reaction, an aqueous solution of an areneous acid reacts with an aqueous solution of an areneous base to produce, okay. Oops, I missed 24. Let's do 25 first anyway. Acid plus base yields water plus salt. You should just know that. That is the neutralization reaction. So if we have an acid and a base, we get what? Salt and a water. Okay, here's the question I tried to skip. Which compound is an areneous base? Well, if you forget how to tell the difference between an acid and a base, please use your reference table. Go right here. Okay, so if you look, we've got NaOH, KOH, CaOH2, and then the one weird one, ammonia. So in general, when I'm looking for bases, I'm going to look for OHs. So do I have one that looks like that? I sure do, right here. This is an organic acid. And how do I remember that? It's the one they almost always show you. That's the one that's put there to confuse you. But look, right here, that's ethanoic acid. Okay, it is not a base. Okay. According to one acid-base theory, a base is an, okay, so remember, acids have H's, so they're giving them away. Give away the H's, okay? Bases, on the other hand, would be the acceptors. So this would be a Bronsted-Lowry acid, a Bronsted-Lowry base. Based on table N, uranium 238 and uranium 235. Okay, so let's go down here. 235 and 238. They have the same decay mode, but they have different half-lives. You see that? That's a big difference. Okay, they have different half-lives. This is not even in table N, so that should have been a clue. All right, just a few left. A change in the nucleus of an atom that converts the atom from one element to another is called, so do you remember that? Changing from one element to another, a type of nuclear reaction. And the only one I see here is a transmutation. Which radioactive emission has the greatest penetrating power, but the least ionizing power? Okay, so if we're talking about penetrating power. Here's how I remember it. If I look here, if I have a big mass number, I don't have good penetrating power, because that means I just get blocked by little things. Okay, so this does not have good penetrating power, and neither does a proton. You see how they have a mass number? So that's going to help me eliminate alpha particle. So far, that's it. Okay. Now the bottom number is charge. And if something has a charge, it would have some good ionizing power. Okay, so that allows me to eliminate positron and beta particle. So what's left? Gamma rays, super dangerous, can penetrate a lot, but they don't have a lot of ionizing power. And which statement describes a benefit of using fission reactions? What is fission? That's taking a little atom and a little atom like this, and usually this, something like this, and making a bigger nucleus. So two little nuclei make a big nuclei. Why would this be beneficial? Okay, well, first of all, gamma radiation is produced does not even sound like a benefit. I wrote the wrong kind. This says fission. Oh my goodness. See, good thing I double checked. This, which I just showed, was fusion. Oh, thank goodness. Fission. What is fission? That's taking a big giant nucleus, hitting it with a neutron, and then breaking it apart into some smaller nuclei. Whew, thank goodness. I realized that and corrected myself, which is why I should always go back to the question, because I was suspicious when I looked at this answer. But a benefit of using either of these, for that matter, is that we get large amounts of energy. So even though we have radioactive waste, that's not a benefit, that's a risk. Nuclear fuel consists of stable isotopes. Well, that's just not even true. Nuclear fuel has to be unstable. Otherwise, why would it decay? So large amounts of energy are produced per mole of reactant. That's always a benefit of a nuclear reaction. So remember, just to be clear, as I started to say the wrong thing, this is fusion, taking two little ones and making a bigger one. Fission is breaking apart a big nucleus. Okay, and that is the end of part A, the first 30 multiple choice.